Driven by an insatiable curiosity to explore the universe and its secrets, humanity has embarked on a journey that defies the boundaries of time, in search of answers to questions that haunt the very fabric of reality. The James Webb Space Telescope, with its keen eye, has just discovered a cosmic structure that predates the birth of stars, a celestial anomaly that appears to be older than the universe itself. How can a structure be older than our universe, you may wonder? Is the Big Bang Theory wrong? Join us to learn how the James Webb Telescope discovered a 13.8 billion-year-old structure and its far-reaching implications. Imagine looking out into the vastness of the universe, where stars and galaxies perform a dazzling dance of light and gravity, revealing secrets of the past and future. That is what the James Webb Space Telescope, a spectacular space probe, does every day, recording and transmitting its breathtaking observations back to Earth. Recently, it revealed a breathtaking sight, a 13.8 billion-year-old celestial structure that challenges the very foundations of our understanding of the universe. Through this remarkable technological marvel, we are confronted with a profound cosmic mystery that is intimately linked to the very fabric of space itself. This shocking discovery has sparked a wave of debate and explanation in the scientific community as it attempts to unravel the paradox of this ancient structure. Top scientists and top observatories around the world are constantly bombarded with questions about this puzzling phenomenon. The most common of these is, how could the James Webb Telescope detect a structure that is older than the universe itself? To answer that question, we first need to zoom in on this structure. It's not a galaxy, a nebula, or a black hole. It's a star, a very old and very special star. Located more than 200 light-years from Earth, near the constellation Libra, it's called HD 140283, but it has a more appropriate name, Methuselah's star, after the biblical figure who lived to be 969 years old. This star isn't just old, it's fast. It's hurtling through space at over 800,000 kilometers per hour, revealing its tragic history. About 12 billion years ago, our predecessor galaxy, the Milky Way, swallowed a dwarf galaxy that was its original home. What makes Methuselah's star truly fascinating, however, isn't its speed, but its age. It's one of the oldest celestial objects we've ever observed, and its age defies logic. Early estimates put the star at around 16 billion years old, but the most recent estimate is 14.46 billion years old, with a margin of error of 0.8 billion years. This number poses a problem because the age of the universe, as determined from observations of the cosmic background radiation, is about 13.8 billion years. How could a star be older than the universe itself? It seems impossible. This paradox has led to questions about the age of the star, the universe, or the accuracy of dating methods. Could the star be a remnant of an earlier universe? Could the universe be older than we think? Could our dating methods be wrong? Let's explore these possibilities in more detail. First of all, we need to understand that measuring the age of celestial objects is a difficult task. Stars like our Sun maintain their brightness, temperature, and size for billions of years, making it difficult to estimate their age. Astronomers take subtle changes in brightness and color over time and compare these measurements to mathematical models that predict how stars change as they age. One of the main indicators of a star's age is its rotation rate. Stars slow down over time, just as a spinning wheel slows down due to friction. By comparing the rotation rates of stars at different ages, astronomers have established mathematical relationships to estimate their ages, a method known as gyrometry. Another indication of a star's age is its magnetic activity. Magnetic activity, such as flares and bursts of energy on the surface of a star, decreases as the star ages. Astronomers have developed advanced techniques, such as asteroid seismology, to study the oscillations on a star's surface caused by waves traveling through its interior. These oscillations change as a star ages, allowing more precise estimates of its age. For example, using this method, astronomers have estimated the age of the Sun to be about 4.58 billion years. Returning to Methuselah's star, astronomers have determined its age by looking at the number of stars it is surrounded by. Stars in the universe can be classified based on the amount of heavy elements or metals they contain. Our Sun is a population-sized star that contains a significant amount of heavy elements. In contrast, Methuselah's star is a population 2 star that contains less heavy elements, especially iron. This means that the star was born before most of the heavy elements in the universe had been created, which happens in massive stellar explosions called supernovae. There is also a hypothetical type of star called a population 3 star, which is thought to contain almost no heavy elements. These stars are thought to be the first stars to form in the early universe, shortly after the Big Bang. They are extremely massive and hot, burning their fuel very quickly, converting hydrogen and helium into heavier elements. When they die, they explode as supernovae, scattering some of these elements into the surrounding space. Group 2 stars arise from gas clouds lightly polluted with these elements, while Group I stars arise from gas clouds enriched by subsequent supernovae. The existence of Methuselah's star raises a puzzling question. How could it be older than the universe itself? The answer is not simple because it involves a lot of uncertainties and assumptions. According to measurements from the Hubble Space Telescope, there is a 70% chance that Methuselah's age is between 13.66 and 14.26 billion years old. Therefore, there is a 30% chance that the star is outside this range, and a 15% chance that the star is even older. Taking all factors into account, there is at least a 20% chance that the star's true age is younger than the true age of the universe. It's like rolling a standard 6-sided die and getting a 6-sided die, which is unlikely. But this also assumes that there are no other sources of error or bias in the age estimate. However, there is no denying that Methuselah's star is incredibly old. In fact, it is the oldest star in the universe whose age has been determined with any reasonable precision. Instead of wondering whether it could be more than 2 billion years older than its surroundings, we can approach the question from a different angle. Could it be that the universe is not as young as scientists originally thought? In fact, it's hard to grasp the magnitude of 13.8 billion years. If we squeeze the entire history of the universe onto a cosmic calendar, with the Big Bang as the climax of the New Year's fireworks, Earth wouldn't appear until late December. Recorded human history would cover just the last 10 seconds of December 31st. Scientists have calculated the age of the universe by observing the light of stars born just a few 100 million years after the Big Bang. As the universe expands, it stretches this ancient light, making it appear redder. This is called redshift. By measuring both the distance and the redshift of these stars, scientists can infer the age of the universe. However, recent discoveries by scientists at the University of Ottawa suggest that the universe may be much older. They propose that it could be around 26.7 billion years old. Renata Gupta, a physics professor at the University of Ottawa, discusses an old theory by Swiss astronomer Fritz Zwicky dating back to 1929. This theory states that photons lose energy as they travel great distances over time. This contradicts the observed data on redshift, but Gupta argues that by accepting this theory along with the expansion of the universe, we can see redshift as a composite phenomenon that is not caused by expansion alone. The increasing age of the universe could shed light on some long-standing cosmic puzzles, as well as some new ones raised by NASA's James Webb Space Telescope. Gupta arrived at the age of 26.7 billion years by combining the tired theory of light with the idea of an evolutionary coupling constant, first proposed by theoretical physicist Paul Dirac, meaning that interactions between particles can change over time. It is important to note that scientists have changed their estimates of the age of the universe. For example, in the 1920s, Edwin Hubble suggested that the universe was only 2 billion years old. However, our methods have become more and more accurate over time, and doubling the age of the universe is a huge step forward. It remains to be seen whether astronomers will change their views on the age of the universe based on Gupta's work. But whether recorded human history is only 10 or 5 seconds on a cosmic scale, one thing is certain. The universe is an ancient and beautiful place. Shifting our attention away from the age of the universe, there are some fascinating observations of the Milky Way. Recent measurements have shown that stars at the edge of our galaxy move much more slowly than similarly located stars in other galaxies. Several reasons could explain this. One is that our galaxy may contain a very small amount of dark matter, an invisible substance that influences the gravitational structure of cosmic objects. Another possibility is that our knowledge of dark matter, including how much of it there is in the universe, may be completely wrong. The mystery stems from data collected by the European Space Agency's Gaia satellite, which provides detailed information about the speeds and locations of nearly 2 billion stars in the Milky Way. These precise measurements are causing astronomers to rethink what they know about dark matter and its relationship to the universe. In the vast universe, dark matter remains one of the most fascinating and elusive mysteries facing modern astrophysics.